Hi, as Carlos said, my name is Marco. I'm here to talk about driving your domain using examples. I'm a technical team lead at Inviqa. In my free time, I develop games, so I do quite a lot of development. And let me talk to you about new projects. So you start a new project, and everything is a green field. You can do whatever you want, and this time you're actually going to do it the right way. So you have conversation with business, they tell you what they need you to do. You go back to your computer, start writing code, and then actually, everything suddenly changes, and business comes back to you, they start asking you for changes, and suddenly you're in development hell, and you have to dump some of the stuff you've done. Some of the new features you're being asked to do is like, oh, we can't really do that now, it's going to be really hard. And so how did we end up here? Well, because change is a normal thing to happen. But at some point you're asking, well, why don't they stop changing their minds? Like, they asked us to do this, and now they come back to us and say that they want something else, which wasn't what they initially wanted. Well, that's because it's actually very fair and normal to have change. A business that doesn't adapt to change won't be very successful, and it will probably be out of business pretty quick. So it is normal. It is something that us as developers have to live with, and we have to be prepared to deal with it. Also, this change might be because there was some communication failure. You were having a conversation with someone. You both thought that you were talking about the same thing, but actually you had different understandings of what was needed, of what was wanted. Or the business needs suddenly change. Suddenly, for some reason, this business has to support mobile because their customers are moving towards mobile, and they actually have to introduce this now, and you have to support it, so you have to maybe make an API or something that you didn't have to do before, or some competition that may show up, and you kind of have to respond to that really quickly, and you have to adapt. So how can we deal with change then? Because it's something we have to deal with. Well, one way to deal with change is by having a short feedback cycle, which allows you to adapt quickly. So you can show what you've achieved every couple of weeks. You can have daily updates so that people will know if something is going wrong really quickly and try to adapt. And this is basically agile, right? So I was just describing some of the ceremonies of Scrum, basically the retrospective and the review and the daily Scrum. And so Agile is about short feedback cycles and finding out about change and what's going wrong as soon as possible. So this will help you with communication failure and short-term changes, but doesn't really do a lot to help you deal with longer-term business changes. So you need to do something else, and what else can we do? Well, actually, we can try to shorten our feedback cycle and try to have this as a way to help us deal with longer-term business changes. And this we would do through BDD. So BDD differs from TDD in the sense that it is a design exercise rather than a testing exercise, and the idea is that it will help you drive the design and architecture of your application. And then incidentally, in the end, you will end up having tests as a consequence of this, but you're not writing those tests. You write the examples of the code you like to have, and because they are examples, they can actually prove that it works as this example tells you about. So how does it shorten the feedback cycle? Well, you have the story level BDD, which is a higher level, at a higher level where BDD is happening. And you write an acceptance test, failing acceptance test, which will drive you to go to a lower level, an unit level, where you are doing spec level BDD, where you are actually writing examples of how you want your classes to communicate with each other. Again, these examples will start red. You then write the code which will make them green, and then you refactor and you repeat this loop as many times as needed to get your story level example green. So in PHP, which is the language I'm going to use for these examples, we usually use Behat and PHP spec to do this. And you can also use PHP unit. It's not as appropriate for doing BDD, but it is possible to do it as well. But PHP spec will actually help you doing this. But I'm actually going to focus on Behat today, not on PHP spec. And I'm going to talk about a specific way of using Behat, which is something that can be called modeling by example. And it helps you deal with long-term business changes by reducing the gap between business language and your code, so that basically the code and business are kind of talking in the same language, so there's less of a gap and you can adapt and easily change your code. So this is a framework to help you uncover your domain and unify the language you use across the board and during your development cycle. The benefits is that you end up having a nice isolated domain, usually a really simple one that reflects the business language and reflects the problem you're trying to solve rather than an arbitrary solution that you can come up with at some point. So we're going to be focusing on story level BDD. As I said, the higher level part of that loop I showed up earlier, and the examples I'm going to use will use Behat. And this helps bridge business and code and confirms that the acceptance is met, so that you're actually writing something that complies with the acceptance criteria that you have. The way you do this is you create a thing on Behat. You have these things called suites, which allow you to have the same examples running with different sets of implementations. So you will have one implementation that will go directly through your domain. It will instantiate your domain classes and go through those. You can have a UI suite that goes through UI, maybe browser one, or you can have a mobile one as well. And this specific one, the domain suite, will be calling some inexistent code that you wish you had, and this code, when you write it, will become your domain, the domain of your application. So if anyone doesn't know what this is just a gherkin scenario. Pretty typical one. I've seen several like these in several different places. And in this case, this scenario, we're trying to describe, let's say we have some application that provides some service or sells something. And in this, we're integrating with a payment gateway called AwesomePay. So what's wrong with this scenario? Why do I find problems in this scenario? Well, first of all, because if you look at this scenario, you will find that it has a lot of implementation details. So it's describing parts of the solution rather than the problem. So the first one is that it says that you're pressing a place order button. So you're actually just describing an action rather than the acceptance criteria or what the business wants to happen. No one wants you to press a button. People just want you to be able to pay. So do I need to explain to anyone how Gherkin works, the structure of Gherkin, or does everyone? I'll just explain anyway. Okay. So the scenario line, it's basically just informative. It just tells you what you're describing. Then you have the given, which can have as many ands as you want. The given is the setup for your example. It just allows you to get to a state where you can start describing your behavior. Then you have the when, which is the input of your behavior. It's the actions needed to take to make this behavior happen. It can also have as many ands as you want. And then you have the then, which is the outcome of this behavior. Again, can have as many ands as you want. So in this case, we want to get rid of the place order button. So we remove this one. And if we look at this, we see that we have a lot of, I fill the expiry date and I fill the CCV. So we're filling a lot of forms. So that's also not part of the behavior. That's just, again, implementation details. And this is a specific kind of UI. If we're, for example, going through an API, we're not going to be filling any forms. So if we want this to be able to be used via UI or via an API, via mobile, or different ways of using it, we can't have this here. And also we can summarize and make it just credit card number, because in this scenario we're just doing an API path where you don't need to validate CCVs or dates, so let's make it shorter. So by removing all of these implementation details, this highlighted something already. And what it highlighted is that our when is actually just a given. We just say that we have a credit card. This is just part of the setup. It's something we need to have, and it's not part of our behavior. And it also highlighted that this scenario didn't really have an input, so it didn't describe a behavior. And because we had all of that implementation, and we were looking at the browser as if it was part of something that we cared about in this scenario, we missed the fact that we didn't really have a description of a behavior. So let's add a behavior, because what we really want to achieve here is to be able to pay. So when I pay £42 using that credit card, then the payment should be accepted. So this is now showing us what we're trying to achieve, shows a behavior, rather than just showing us how to fill forms and press buttons and tell people about these browser related things. So next thing we can look at and think about removing is if we see the given awesome pay as a credit card payments enabled, we can actually remove awesome pay and replace it with a generic payment gateway. So you might be asking, okay, so if I'm doing this implementation which is specific for one payment gateway, I don't care about any other payment gateway, why am I removing it from my scenario instead of having it there? Why am I using this generic term payment gateway? Well, this is actually quite an important step, because by removing the name of the payment gateway and replacing it by a generic thing, you identify that there's a concept called payment gateway inside of your domain, and that awesome pay is something that is outside of your boundaries. It's something that you don't control. It's something that you don't want to be in your domain. So what this tells you is that payment gateway will be an interface, and then you will have an implementation of this interface, which is the awesome pay. Or later, if you want to have a PayPal, then you just need to make an implementation of this interface that hides all of the PayPal implementation or WorldPay implementation or whatever you want to use. But your domain doesn't need to change just because you decided to support a new payment gateway or to replace this payment gateway. So outside change doesn't really creep into your domain. Your domain is now bounded and isolated. So you end up with something like this. You have your domain, and you have interfaces around it, and your domain is now bounded by these interfaces. And outside of it, you have all of these external dependencies that you need to have, and everything speaks to your domain through this interface. Or these interfaces, a group of interfaces that you define, which are the boundaries of your domain. So back to our scenario. This is how it looks now. Given the payment gateway as credit card payment enabled, and I have a credit card with a certain number, and the credit card has unlimited funds on payment gateway, and when I pay £42 using that credit card, then the payment should be accepted. Okay, so let's start implementing our domain suite for this. So this is the one implementation that will go directly through our code rather than through some UI. So we now have a step that says this payment gateway, a new fake payment gateway. So we're using a fake payment gateway, which is an implementation of this payment gateway interface that I've mentioned before. This is just a bit of boilerplate that we need to have here, but if you look at the code, which just says this payment gateway as credit card payments enable, you will see that it mirrors the language that we used to describe our steps. So the language you can see on top, it says given the payment gateway as credit card payments enabled, and the code says this payment gateway as credit card payments enabled. So it's pretty similar. The language you used to discuss this with business and now the language you're using to create this in code are very similar. So we go to the next step. Given I have a credit card, so we just store a credit card. This one doesn't really have much to it, although you might notice that we're passing a number and we are type hinting to an object. And this is a Behat feature called transformation, where you can define a method that will take the input from your scenario and will replace it with whatever this transformation returns. So what this means is that we're now uncovering domain objects. So we identified that we have this concept of credit card inside of our domain, and we're now creating this. So we're already creating, our domain is kind of emerging from these steps. So we're uncovering domain elements. This credit card in this case will be a value object, so it is immutable, it has no side effects. It has a type, so you get this free validation, because before you just had a number and that number meant nothing and you had to kind of check that this number was correct everywhere. Now you just have a credit card. It can be a complex value, although in this case it's just kind of wrapping a number, but it could have a date, it could have a CCV, and it just represents this value in a specific state that doesn't change. Or you can have, like, for example, let's say you have a number like 80 and 60. It doesn't mean anything, it's just two numbers, right? But if you have this in a value called crop, you immediately know that this will be the width and height of a crop. So it's encapsulated inside of this immutable object. It gives you a name for this object, and it gives you a type that can be validated through type hinting anywhere. You might also have noticed that there's a static call there, a static constructor. So this is a named constructor, which helps you encapsulate your behavior by hiding your anonymous constructor. So you don't really need to look at the code to see how to build your object, because you have a method that tells you that you're building it from a number, so you expect to be able to pass a number. It also gives you improved readability. It gives you some ubiquitous language, because that's how you speak. It's very similar to English again, rather than new object and then some random parameters that you have to look up or rely on your IDE to give you that information. So your class becomes more of a black box. You don't need to look inside of a class. And it also allows you to have different named constructors. So you can have one that allows you to build from number, one that allows you to build from number and CCV. So you just name them based on whatever you want to use to build these objects. So let's go to the next step, which is given the credit card as unlimited funds on payment gateway. So the implementation of this one is this payment gateway cards has unlimited credit, this credit card. This kind of looks a bit awkward. It doesn't mirror the language, and there's no easy way for us in code to mirror this language. So this is a thing that can happen, and it will happen frequently. And in this case, you will have to go back and play with the language a bit. So we might need to change our step and reword it to make a bit more sense, to be more code friendly. So let's change it from the credit card has unlimited funds on payment gateway to the payment gateway has unlimited credits for that card. So let's see how we can implement this now. And now we have this payment gateway has unlimited credits for this credit card, which is pretty similar again to the business language that we used originally to describe our feature. So what are the benefits of this? So you have code that is closer to business language. So it leads to modeling the domain rather than an arbitrary technical concept, because you are driving your code from the description of the problem you're trying to solve. And it means that the code will change to reflect domain changes rather than arbitrary changes on infrastructure or some other technical requirement. So in other words, so the code changes when business changes, and our domain only needs to change when business rules change, because it's now isolated from all outside influence. Business logic is also the most likely part of our application to change, because when someone comes back to you and asks you that now we need to support this, now we need to do that, it's usually a business requirement, not a technical requirement, although it might happen to have also technical change. You might want to change databases or whatever, but this also helps you with that, because it means that in this case, if you have an infrastructure change, it won't touch your domain. If you have a domain change, it doesn't touch anything outside of this domain. You also get this emergent design, because your design emerges from our examples, and our examples emerge from conversations with business. You do that gherkin example that you get it by talking with your BAs, talking with your PMs, talking with whoever owns the feature, with your product owner, the people that know what they want, with your stakeholders. Also, this technique often leads to situations where known patterns apply, such as builders, value objects, interfaces, and all of these things I've mentioned before, named constructors. It also helps you with decoupling, because you get your bounded domain is isolated from all the boilerplate and technical solutions. Your business logic is isolated from infrastructure. And it helps you also separate from legacy code, such as a framework. If you're using a framework, you don't want your framework to go inside of your domain, because at some point, if you want to migrate to something new, you will also want this framework to communicate with your domain via those interfaces. So if you do something like this and you have your domain bounded by these interfaces, and you, for example, using Zen framework, and you want to replace it with Symfony, you just need to re-implement some interfaces, do some framework boilerplate, which might be some substantial amount of work, but it's still less than if you had to go into your domain and change it everywhere where you're using the framework. So this also mitigates communication problems, because it reduces the gap between your code and what the stakeholders are talking to you about. And it drives developers to have a better understanding of the business, because first of all, you have to have these conversations with your stakeholders to extract this information, and then because you're talking the same language as them when you're writing your code, you will know better and understand better what business wants and what they're trying to achieve. It makes for easier development, because the code talks about the problem it's trying to solve rather than the solution. And let's say that if you implemented something, and I know nothing about your implementation, and I need to change it, I know the problem I'm trying to solve, so if that code is talking about the problem, I can probably find my way around that code. But if it's talking about some arbitrary solution you came up with and I know nothing about it, I will have to spend some time trying to understand why things were done this way and what is this class here doing. It's also easier to return to the code base, because it mirrors natural language, and so it will tell you kind of what it's doing, and it's easier for new developers to understand because of these reasons that we just said. It's not talking about some arbitrary solution that you decided to do at the point. It's talking about the problem you're trying to solve. You get free documentation, first of all, because the gherkin will document all the business requirements and tell you what it's doing, and also because by reading the code, you're kind of already reading what it does. You get free tests, because this is a design exercise, so this is something you did to get the benefit of getting this simple architecture that mirrors business language, but in the end, these examples can be run and prove that if your code satisfies these examples, it's because it is doing what is expected of it. It makes it easier for QAs as well, because the gherkin scenarios are focusing on behavior and not on implementation, so they are they can look at it to know what is expected to happen rather than how it's being used in the browser. Also, it doesn't prime the QAs to test things in a certain way. So if they're reading something saying that I need to fill this form and press this button, that's probably what they're going to do. If you describe the behavior but you don't tell them exactly how to test it, they can come up with their own way of doing things, and they might find something that they wouldn't if they were primed to do things in a different way. It makes it easier to respond to change, again, because of the unified language, or because of the proximity between the requirements and the code. But what about end-to-end tests? So now you have your domain tested, but you don't really have a test that goes from outside to the end of your application. It doesn't go across the whole application and test things. So as I said earlier, we have a suite, which is the domain suite. And this is, in Behat 3, you support different suites and different implementations for the same set of scenarios. So for the same gherkin that I showed earlier, you can have different implementations. And what you do is you can define domain, for example, domain 1, which is the one I just showed up. And then you can create, for example, a web context, which only runs the scenarios that are tagged with web, for example. Or it can have no tags, and then it will run both of the scenarios with both implementations. One goes through the browser, the other one doesn't. You can filter it by negating a tag. In this case, domain will not run tags that are marked as UI, because you might have some scenario that is UI specific and you don't want it to run through your domain. You can have as many as you want. You can add a mobile one. You can add an integration one as well, which just runs UI, for example. So in sum, you end up with a bounded domain, isolated and decoupled from other parts of your application, and decoupled from frameworks as well. You get a better understanding of business domain. You get reduction of communication gaps by having this ubiquitous language that your stakeholders talk, and your gherkin talks, your implementation steps as well, and then in your code, you're speaking the same language across all of these steps. Easier development, because your code becomes more readable, because it mirrors English rather than just technical concepts. The code talks about the problem, not about the solution, so it's also easier to develop. And emergent patterns, as I mentioned earlier. Quicker CI builds as well, because what you can do if you have domain context is you run this domain context, which is going directly through code. It doesn't go outside of your domain, so it's pure code. There is no infrastructure there. It runs pretty quickly. And then you can have just a few end-to-end tests that go throughout the whole thing, testing the critical parts of your application that you really want to check that this one actually goes all the way and does everything. And the rest of the domain, you can just run this domain suite that actually tells you that your logic, your domain logic is safe and sound and it's working. Easier handover because of the documentation you get. And it's also easier to get into the code. And the code is more maintainable because it changes to reflect business changes. And that's it for me. Thank you.